New Thinking Aloud is a non-profit endeavor. Your contributions to the New Thinking Aloud Foundation make a meaningful difference in our ability to produce new videos.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. Today we are going to talk about purpose and value in science, and my guest is Arthur M. Young, cosmologist, inventor of the Bell helicopter, founder of the Institute for the Study of Consciousness, and author of The Reflexive Universe, The Geometry of Meaning, and the Bell Notes. Welcome, Arthur.
Hi.
It's a pleasure to have you here. You know, in science in general, purpose and value seem to be talked about, at least in the social sciences and management sciences. But then as science reduces down to psychology, to biology, to chemistry, to physics, it seems as if purpose and value are done away with entirely, to the point where they say there is no such thing as purpose or value in the physical universe. You take a different view, don't you?
Well, there's a perfect good reason for leaving out purpose, because it doesn't have any explanatory value. And I'm familiar with it, for instance, in patents. You can't patent the purpose to fish or the purpose to fly. You can see why. It's ridiculous. But if you show a device by which you can fish or fly, then you can patent that. So purpose is out so far as describing a patent is concerned. And it's rather similar in science because it doesn't have any descriptive value. Now, as for value, that's a different thing again. I think that science does deal with what corresponds to value. Do you want me to take off on that? Or?
Well, in the physical sciences, you mean?
Yes.
Well, yeah. Let's talk about that, because so often science says we are value free, that right. Anybody can replicate an experiment regardless of their religion, their race, their creed, their color, because values don't enter into physical science.
Well, that's has to do with the methodology. In other words, you must be objective. You can't put your hand on the scale. You can't bias the results. It has to be value-free in that sense.
In sociology, there's a big argument that says that that's impossible, that nobody is really value-free.
Well, it is possible to make an experiment without putting your hand on the scale.
In the physical sciences, it is.
In a literal sense. But that's quite a different thing from saying there are no values in nature, or that the world doesn't. You see, to me, value is not objective. I think everyone would agree to that.
Yes.
And that's one reason it's left out of the scientific method, because the scientific method has to be objective. But that doesn't mean that the things you're dealing with are entirely objective. I mean, how could everything be objective? Then what is the meaning of projective or subjective? It has to be one to be the other.
Well, perhaps we could just define these terms as you use them.
I use the word projective to get away from the personal. The word subjective implies that it's in a person's head or in their feelings. But what's subjective to you is not objective to me. I can see your face, I can see your suit, but I can't see your feelings. Your feelings are something you alone feel. But that doesn't mean they're not subjective to me. My feelings are subjective to me. So the more general word is projective. I can say your feelings are projected by you and my feelings are projected by me. Projected in the sense that your feelings, if you feel badly, then everything looks gloomy.
So I might describe the world about me by projecting my internal reality
Right.
out.
And that wouldn't help if you were doing experiments. You might even foul up the experiments just because you were feeling fouled up yourself.
I mean, in principle, scientists are not supposed to do this.
Right. And let's say that's a good goal. But that doesn't mean that reality doesn't have this projective aspect. And where it appears in science is with forces. Now, of course, science deals with forces.
Yeah.
But let me take you off a little bit now.
Okay.
Suppose I were to say, we're talking about business, and suppose I were to say there's no such thing as value, everything is forms.
Okay.
Well, that would be ridiculous, because the businessman doesn't care about the forms. He invests his money in one thing and then changes it into another and then into another. That's hence the term liquid assets. And the more liquid a business is, the more money it's likely to make. If you get stuck on the form aspect, you'll go on making something that's obsolete and can't sell it.
I suppose it might be fair to say that a businessman is mostly concerned with value.
Right. Well, it would be very foolish to say there was no such thing as value if you were in business.
Right.
You shouldn't be in business if you said that. Well, it's similarly wrong to say there's no such thing as force in science. Even though force cannot be objectively described.
But in physics, one hears about the so-called the four forces: gravity, electromagnetism, the weak force, the strong force. I get the feeling, you know, as not as a physicist, but as a layman, that they think they can objectively describe these forces.
No, but that's just it. They're stuck when it comes to describing a force as a force, so they substitute something. It could be saying it's the bending of space-time. Now, if that means anything to you, fine, but it
That's
doesn't
how
mean
gravity
much to
is
me.
described, and it's always been a puzzler to me, too.
The alternative is to say it's a shower of gravitons. Well, how could a shower of gravitons cause things to attract each other? Now, I'm just bringing out some of the foolishness of it. Maybe I'm not doing justice to science, but I'll try to do justice. Because, for example, suppose you say that a shower of gravitons is causing gravity. Well, the reason they've invented these hypothetical gravitons is because there's something like they want something like light, which is radiated. But then, if we turn to a black hole, now I think everyone knows what a black hole is, but it's defined as something that's so dense, so heavy, that light can't escape from it, can't radiate from it. Well, then how could the gravitons radiate from it if they're to be modeled after light? Well, at any rate,
And yet it has intense gravity is the whole point
Right,
of the black
right,
hole, that the
right.
gravity is stronger than the light.
right, that keeps the light from radiating. But if the graviton is so named to be like light, how could it be radiated?
Well, these are paradoxes in physics, and I guess what you're saying is we should look at these paradoxes because they tell us something, and other physicists often tend to say, well, we should just ignore the paradoxes and deal with what we do know about.
Well, I'm talking about these paradoxes, but they're more than that, they're ridiculous. And I think we should go on further, though, but I don't want to labor this point. I'm just saying that forces cannot be described conceptually.
Right. Well, I think what your point is, or the point you'd like to bring us to, is that from the notion of the forces in physics, we can derive a concept of value in nature.
That nature is full of values. Protons like electrons. Protons don't like other protons. They repel one another. How do you explain this? How do you describe attraction? In order to describe attraction, you can't do it conceptually. You have to say, well, it's like I'm attracted to a beautiful girl.
And I think most physicists, if they were really honest, would admit that physics hasn't yet explained the basic concept of attraction.
Well, it's all right not to explain it.
Uh-huh.
I'm criticizing putting it under the rug and saying that you've accounted for it by a shower of something or other. Mind you, the shower in the case of electricity, it has to go both ways. You have to have a shower that attracts and another shower that repels. And these have to be going on both at once.
And you seem to be saying that a better analogy would be our own feelings, our own emotions.
To just accept that nature, like ourselves, has emotions, forces. What does the emotion come from? Something that causes motion. Well, that's precisely what causes the motion of the planets, is forces. And it causes the motion of electrons, motion of everything. So motion and the forces which cause motion are as much part of nature as are these forms and shapes which you can describe conceptually. So what this really boils down to, and it's time for the psychologist to come in, is that there are other faculties besides concept, intellect. There's a feeling faculty and a sensation faculty, of course, and it's when we come to the intuition faculty that we things get really interesting in science.
What you're saying is that it's perfectly legitimate to take the scientific attitude that all of nature is in effect alive. It has feelings as we have feelings. That this is not the anthropomorphic heresy, that there's something to it.
Well, that's going even further than I am. I'm perfectly willing to do that, but I'm only asking scientists to recognize that there's a cosmological entity called force, which is if anything more basic than the particles. And this is just what they find, because you begin with objects like bricks, you take them apart and find molecules. Now you're still dealing with particles.
Right.
Then you take the molecules apart, you've got atoms. They're still definite things and they have an identity, and you can say this atom is different from that atom.
Right.
But what happens when you take atoms apart? You get forces. Now they will tell you get protons and electrons, but protons and electrons are only the, as it were, poles of forces. The force is so much more important than the electron and the proton. Its measure is 10 followed by 39 zeros times gravity. Now that force is utterly beyond anything we can conceive of in our own lives, but it is more basic than the things called particles.
If we're not even clear, as I understand physics, that these particles are really particles at all anyway.
Well, I'm perfectly willing to call them particles if that's what they want to call them, but they don't have identity. You couldn't tell one particle from another. Or if an electron went into an atom and then an electron came out, you wouldn't know whether it was the same electron. It's a value. And I often use that thing about a dollar bill. Let's see if I have one.
I happen to have a Greek drachma here. Will that work?
Well, that's rather uncommon. I wanted something like a dollar bill, but suppose I had a dollar.
Okay.
Suppose you lend me a dollar, and then I pay you back next week, the following week.
Okay.
You don't look at the dollar and say, that's not the dollar I lent you.
Right. No, it wouldn't matter to me. And if we were in Greece, you could give me any drachma back.
Right. Well, that's what I mean by identity doesn't matter at the value level. In fact, here's another thing that you could put in your book for saving the immortality of the soul. This is one of the things that scientists can't cope with. But suppose I were to set a match to a dollar bill or a $100 bill. What happens to that value?
It's gone.
No.
Oh, all right. What happens?
Do you know how much in debt our government is?
Trillions of dollars, I think.
Well, suppose I were to collect $1 trillion and burn it.
Okay.
How would U.S. be?
Oh, the debt wouldn't be any different, would it?
No. The debt would be gone.
Well, you've confused me.
I confuse you? Well, the dollar bill is an IOU from the government.
Right.
Originally, they would pay you in gold. If you burn an IOU, there's no more debt.
Okay.
In other words, if I wanted to give my money to everybody, I'd burn it. It would make everyone that much richer.
Uh-huh.
Because there's a constant value. That's what countries do when they start printing more money. The money becomes worth less
and less, yeah.
Ultimately worthless.
Mm-hmm.
And we've been printing this money to pay our military and other things, and we have inflation.
Now, how does all of this relate to the notion of value?
Because there's the same conservation of value as science recognizes in the conservation of mass energy.
Uh-huh. In other words, you can't really destroy value. Is that
Right.
what you're saying?
And because you can't destroy value, and because the soul is a value thing, you can't destroy the soul.
Uh-huh. Now, another point that you mentioned there, that you cannot distinguish one particle from another particle, that forces are, in a sense, indistinguishable. Does that apply to the soul as well, then?
No, because the soul is you might say, a possession of spirit.
Mm-hmm.
And that gets us far out. But each person, now, in a sense, what you say is true, that soul is a common possession.
Uh-huh.
But that's really what I would call the group soul.
Okay.
And this is something that animals properly develop.
Mm-hmm.
And that's how animals develop instinct, by developing something that the group soul remembers. This is what Sheldrake refers to when he talks about the morphogenetic field.
Mm-hmm.
But it really should be the group soul of the animal, because it's not a field, it's a program, it's a knowledge of what to do, it's a memory of past experiences.
Mm-hmm.
Well, all right, we too have a group soul in somewhat the sense that an animal has. We have an instinctive way of behaving. But it is man's job as man, as distinct from the animal, to create his own independent soul. And that's what really is most of our trouble.
Mm-hmm.
What, who was it called? I can't think of his name now. Called self-alienation.
Marx and Hegel, is that what you're...
Hegel it was,
Uh-huh.
right.
Yes.
Self-alienation is what everyone does to acquire their own identity. They have to rebel against the group soul, think for themselves.
Mm-hmm. And in a sense, I get the sense that spiritually what we do is we develop our unique egos, think for ourselves.
Right.
We detach from our own sense of oneness with nature.
Well, that's again is a step in this process. Now, what you're talking about is the detachment, in a way, is unfortunate, but it's necessary if we're to learn to think for ourselves.
Mm-hmm.
According to my arc and all that jazz, you eventually give up the ego, but you first have to get the fruits of having the ego, because without it you couldn't learn anything.
But it seems to me what you're talking about now is the essential necessity for us to identify ourselves as separate from our environment, separate from the forces of nature, and at the same time connected, because these are the forces in us and outside of us.
No, I'm saying it's necessary to take on this identity thing, but it's not real. It's not a true
It's not who
separation.
we really are.
We're still connected.
Uh-huh. Which is an important thing for an adult to understand.
I think as I'm neglecting the last step of this argument.
All right.
But what we've been saying is perhaps the most difficult to understand. I mean, the soul thing, or what I call second level, that which is beneath the conceptual or before. It's really part of the unconscious.
Mm-hmm. But
okay.
I just want to elaborate this point a little more, Arthur, because when you talk about the physical forces as being akin to our own feelings,
Yes.
I think you're making an important statement about our integral, innate connection with nature itself.
Right. That is connected with nature, and we're connected together. That's part of psychic telepathy and all that.
Right.
See, the word telepathy, it's not communication at a distance. It's feeling at a distance. Pathy means feeling.
That's right.
Like pathos or pathology. And you're understanding telepathy if you think of it as communication.
Of thought, yeah.
Right.
Well, where do we go from here, Arthur?
Well, I wanted to go back one step further to purpose. This is what you began with, because I've been talking about value. Well, the thing that's in science that corresponds to purpose has only been discovered fairly recently. And this is the quantum of action. This is my central thesis.
Yes.
And I was quite surprised that one of my old students who's been thinking and writing and buzzing around for years now, 10 years I think, since I first started with him. And he said to me the other day over the phone, you mean, he'd been reading something recent, that the quantum of action is spirit or is spiritual? Well, I've been trying to tell him that for 10 years. He finally realized it. At least he realized that I said so. The next step is for him to realize that it's true for himself.
Let's define the quantum of action then for our viewers. What is that?
Well, the quantum of action is what was discovered by Planck. Now, action was known for a long time. It was very mysterious because they talked about things like action at a distance. How could something here affect something over there? This was action at a distance. Well, that's primarily what light does. Light transmits energy from one point to another. And it's action at a distance. Now, what is this action? Well, what Planck discovered, and this was what was very important in 1900, that it comes in whole units. You can't measure different amounts, any amount of action. This makes it analogous to decision. So you couldn't decide to do something 1.4 times. And this is very important. It's much more fundamental than the physical atom. The physical
quantum, in other words, what you're saying is that the universe is basically composed of these quanta of action.
Decisions. Not physical objects. Because if you had a physical atom, you could divide it and divide it again, but you can't divide an action. I can't vote 1.5 times or half a time.
And this is essentially, I mean, it's like consciousness at the very basis of the universe itself.
Right. It's that, because action includes consciousness. I mean, you may act unconsciously, but if you do so, you'll get the feedback and get conscious. This is part of the process of growing up, is to make unconscious actions and then be conscious of the results. This is the learning process. And that's why God forbade eating the tree of knowledge, because in order to gain knowledge, you have to act on your own. See, if you make a mistake and you blame it on the boss, you don't learn anything. It's only when you can only blame yourself for your mistake that you learn something. And that was a very necessary thing.
In effect, that's why we develop these separate egos, why we become so disconnected from the universe of which at this deeper level we must be at one with.
Well, I said the other day that God started by having a university, invited everyone to come, and nobody came. So he then decided to change tactics, and he said he forbade people to eat it. and that made it very popular. In any case, it's necessary to act on your own if you're going to learn anything.
Well, this is your central thesis, basically that the quantum of action is a unit of conscious decision, and that's what the whole universe is composed of.
Right. Now, I don't know how much proof you want of that, but
there are some.
One way to look at it is it's also called uncertainty.
Yeah.
And you see, if I were perfectly certain of what another person would do, they would have no power over me. It's because I'm uncertain about that person that they can have an advantage of me. You might be a spy or something.
Mm-hmm.
In other words, that uncertainty is their freedom.
Mm-hmm. That's why nations always want to keep each
Right,
other off
right.
guard.
They have all their spying techniques and so on. They're trying to find out what the other nation is up
And we
to.
don't want to tell them, will we or will we not
Right,
use our nuclear
right.
weapons, you know.
Well,
Now, how does this relate to the
this-
quantum of action?
I would say, you see, the quantum of action is also called the quantum of uncertainty.
Aha.
So since it is uncertainty to the observer,
Mm-hmm.
it's freedom to that which is observed.
Uh-huh. In other words, the subjective aspect of uncertainty is freedom. The objective aspect of it is
Uncertainty.
uncertainty, or perhaps even the projective aspect.
Now, there is a very tiny amount of uncertainty even in a molecule.
Mm-hmm.
And as you go down, let's turn to atoms, it gets greater.
Yes.
And it becomes about 1% when you get to nuclear particles.
Mm-hmm.
But when you get to the photon, which starts at all, it's 100%.
Uh-huh.
Now that is a very important.
The photon is 100% uncertain.
Right.
So it represents, I suppose, to us 100% free will at some level?
Yes. But let me point out why that's important.
We have about a minute, Arthur.
Oh, well, then I think I better let it go. I think it'll take a little longer than that.
Okay.
But you get an increasing amount of uncertainty as you get more basic. So if the scientist insists on reducing things to the most basic, he's going to reduce it to consciousness.
In other words, it's as if in the process of reducing science from psychology to biology to physics, science has come full circle, in a sense. I mean, starting with theology, you might
Well,
say.
it sounded like reduction into a simple bricks when you talked about molecules, but if you carry it on through, the ultimate end of this reductive process is the photon, which is pure freedom.
Arthur Young, thank you very much
Thank
for
you,
being
Jeff.
with me. It's a pleasure. And thank you very much for being with us.
I imagine that by now many of you already realize that, in conjunction with White Crow Books, we've just launched the new Thinking Aloud Dialogues book imprint, and our first title is There Life After Death? New Thinking Aloud is a non-profit endeavor. Your contributions to the New Thinking Aloud Foundation make a meaningful difference in our ability to produce new videos.